F will be equal to F1 plus F2 plus F3. So if the resultant force, that is F, passes through the center of mass, suppose this is our resultant force F, which is passing through center of mass. So if this is the case, then all the particles which constitutes this object, they will move with the same velocity. So suppose the object is moving with velocity v and is being acted upon by three forces F1, F2 and F3, and the resultant of these forces, that is F, is passing through the center of mass, then all the particles of this object will move with the same velocity v. Now we will define system of particle. System of particle is region of space enclosed by a hypothetical boundary containing all the particles or objects in our consideration at a particular time. So suppose at any given time we have defined some region like this. So suppose this is the region in question. This is the boundary of this region. So all the particles inside this region, they will constitute the system of particles. So these particles can be of same mass, of different mass, whatever be the case. So this is our system of particle. There may be some particle outside this region, but once we have defined the boundary of our region, only those particles which are inside this boundary, they will constitute the system of particle. Now we'll see what is frame of reference. Frame of reference is the coordinate system with respect to which the position, velocity and acceleration of the mass of particle is defined. So suppose we have a system of particle. Say this is point A and we have particle P1 with mass m1. We have another particle P2 with mass m2. This is point B. So suppose that we have defined a coordinate system with origin at O. So if this is our frame of reference, then we'll try to find out the velocity, position, vector and acceleration of particle with respect to this frame of reference. So suppose this is velocity vector r1, this is our velocity vector r2. If we take some other frame of reference, that is some other coordinate system which has its origin here, O1, then you'll see that the position vector and the velocity vectors and the acceleration vector of these particles will change. Now we call a frame of reference inertial if the velocity of the frame remains constant. It also means that if a frame is at rest, then also that frame of reference is inertial. If the frame is accelerated, it's called non-inertial frame of reference, and Newton's law holds good only in inertial frame of reference. Now we will define a new term called moment. First we'll define moment of a scalar quantity. Moment of a scalar quantity with respect to a point P is given by the product of the position vector of that quantity with respect to P and that quantity itself. So let's see an animation first. So here we have an object and the mass of this object is m. As you know that mass is a scalar quantity, so we want to find out the moment of this mass m. So this moment will be defined as the product of this physical quantity, that is mass m, and the position vector of this object with respect to a point P. Suppose the position vector is r, so moment of mass will be defined as the quantity itself, that is m, into position vector of that quantity with respect to the given point, that is p. So this is the moment of mass m with respect to a point p. If you want to find out the moment of mass with respect to some other point, say point q, so again what we'll do is we'll find the position vector of this mass m with respect to this point q. Say it is r1, so the moment here would be m into r1. So as m is a scalar quantity and r1 is a vector quantity, so we can say that moment is also a vector quantity, since it is a scalar multiplication of a vector, that is a vector is being multiplied by a scalar quantity. Now we will define the moment of a vector quantity. Moment of a vector quantity with respect to a point P is given by the cross product of the position vector of any point on the line of application of the vector quantity and the vector quantity itself. So let's see this first with the help of an animation. So here we have a vector quantity f, and we want to find its moment with respect to a point P. This is our point P. So first we'll define the line of application of vector f. So the line of application will be a line AB. As you can see in the figure that the vector f falls on this line AB. So now the moment of f with respect to point P would be the cross product of position vector of any point which lies on its line of application and the f itself. So let's take a point C on the line of application AB. So the moment would be r cross f, where r is the position vector of point C with respect to point P. So this will be equal to mod r into mod f into sine alpha into n cap. Here n cap is the unit vector and its direction is the direction of r cross f. So n cap is the perpendicular to the plane where vector r and vector f lies, and the direction of n cap is going inside the plane. So the magnitude of moment of f with respect to point P is mod r into mod f into sine alpha, and direction is a vector which is perpendicular to the plane where vector r and vector f lies, and it is going inside the plane. So as the definition of moment says that the point C can be anywhere in the line of application, that is on the line AB. So suppose we take a different point, that is point D, and let's try to find out the moment of F. So again moment would be position vector of D with respect to P, that is R dash, cross the vector itself, that is F. So this will be equal to mod R dash into mod F into sine alpha dash. Alpha dash is the angle which R dash makes with vector F, and the direction would be, say, n1 cap. Here n1 cap is a unit vector. So first we'll see that the vector n cap is equal to vector n1 cap, because both are unit vectors and the direction of both n cap and n1 cap is perpendicular to the plane where vector r dash, vector r and vector f lie, and this direction is going inside the plane. So it is clear that the vector n cap is equal to vector n1 cap. So in order that both these two moments are equal, we'll have to prove that mod r into mod f sine alpha is equal to mod r dash into mod f into sine alpha dash, or mod r into sine alpha is equal to mod r dash into sine alpha dash. So if this equality holds good, it will mean that these two moments, that is r cross f and r dash cross f, these two moments are equal. So to prove this, let's do one thing. Let's drop a perpendicular from point P to the line AB. Let's say that the length of this perpendicular is r perpendicular. So let's take the triangle APD. So in the triangle APD, r perpendicular would be equal to mod r sine alpha, because since this angle is alpha, so this angle will also be alpha, and this is perpendicular, so this is 90 degree. So we can see from here that r perpendicular is equal to mod r, that is PC, into sine alpha. Similarly, in triangle APD, sorry, this is triangle APC. So in triangle APD, again this angle will be alpha dash, so r perpendicular would be equal to PD, that is magnitude of r dash into sine alpha dash. So we can see that r perpendicular is equal to mod r sine alpha, and r perpendicular is also equal to mod r dash sine alpha dash. So we have proved that mod r sine alpha is equal to mod r dash sine alpha dash, which means that r cross f is equal to r dash cross f. So the moment of vector f with respect to point P is r cross f, which is mod r into mod f into sine alpha. It is equal to mod r dash into mod f into sine alpha dash. So as we have seen that mod r sine alpha and mod r dash sine alpha dash is nothing but r perpendicular, so moment would be equal to r perpendicular into mod f. This is the magnitude of moment, and the direction would be n cap. So the magnitude of moment of a vector quantity is the product of the magnitude of the vector quantity and the perpendicular distance, that is r perpendicular, of its line of application from the reference, that is point P. So also the moment of a vector quantity does not depend on the choice of point on its line of application, whose position vector with respect to P is used to calculate the moment. So as we have seen that even if we choose the point C